For this problem, we need to determine the force in each cable and the force set. Okay, so we have this assembly where you have the cables that are running from point A to B to C to D. And what you want to do is to find tensions in cable AB and cable BC. Then you want to find tensions in cable CD. Then you have a lamp with the mass as 4 kilograms. Then you have an unknown force at point C. So to do this problem, we need to draw two separate free-body diagrams. First, we need the free-body diagram at point B, and what you have at that point is the lamp. So the weight for the lamp will be mass times G, and that's going to be 4 times 9.81, and that's going to be in Newton. Then you have the cable AB. We will take that in tension. So there's going to be tension TAB as well as TAB at both ends, and as a result of that, there's going to be a force at B with the same magnitude and at an angle of 60 degrees. So that's one force. Then we look at the cable BC. So on BC again, we will assume that to be in tension. So two end forces on that, let's call them as TBC and TBC. So there's going to be another force here with the same magnitude as TBC, but it's going to be in opposite direction. The angle here is going to be 30 degrees. So that's the free body diagram, or you have all the forces that are acting at point B. Then we're going to draw the free body diagram at point C. So if I look at point C, we have the unknown force going in the downward direction. Then you have the cable with tensions at both ends, and we're going to call this as PCD. So the force which is going to act at point C will be same magnitude as PCD, and it's going to act at 30 degrees. So that's the force as a result of the cable CD. Now we still have this cable attached at point C. So there will be another force here. Let's call this as TBC. So it's going to be the same force as this, but it's going to be in opposite direction, and the angle here will come out to be 30 degrees. So that's what you get as the free body diagrams for point B as well as point C. Now at B, there are two unknowns. You have this one as unknown, you have this one as unknown. So you should be able to write two such equations. I could sum the force in the x direction, and that goes to 0. So take this point, we drop a perpendicular. You have this as the x component, this is going to be the y component. So your x component will be TAB cosine 60, and if I choose this to be positive x, this to be positive y, and then it's in the opposite of x, so that becomes negative. And then you have this force here. It has two components going this way and this way. So now we got TBC, and it's going to be cosine 30. It's positive, so this should add up to 0. So that's the first set of equation of equilibrium. Then we go and we look at y components. So we have this one as one of the components. You get TAB, and you get sine 60. It's going up. Then we have this force going down. So you have negative 9.81. Then you have this component that's also negative. So you get TBC, and that component is sine 30, and that goes to 0.